Hello everyone. Continuing on our integrals, we are now going to look at integration of trigonometric functions. Now let's recall something we have done in differentials, that we all know that d dx of sine x is cosine x. Now, we know that differentials and integrals are kind of opposites of each other. So in other words, the integral of cosine x dx is nothing but sine x plus c. Similarly, we know that differential of cosine x is negative sine x. So the integral of sine x dx, this negative, will come here, which will be negative cosine x plus c. So keep in mind, the integral of cosine x dx is sine x plus a constant, and an integral of a sine x dx is minus cosine x plus c. So once again, let's go back to our differentials here. We're going to look at differentials of a tangent x, because remember, if you take the differential, the tangent should give you secant. That's how we check our results. So we know the differential of tangent is secant square x. So that means when I take the integral on both sides of the equal sign, we will get integral of secant square x dx to be tangent x plus a constant. Similarly, we know a differential of secant x. It is secant x tangent x. So when you look at the terms of integral, the integral of secant x tangent x dx is secant x plus a constant. And similarly, we can find that the integral of cosecant square x dx is minus cotangent x plus a constant, and integral of cosecant x cotangent x dx is minus cosecant x plus a constant. Let's do some examples here. Okay, let's look at the first one. We're looking at an integral of t to the 4 minus cosine t dt. Now keep in mind the power rule. The most powerful rule, guys, for us in integrals is the power rule. That is x to the power n dx. Is written as x to the power n plus 1, the whole divided by n plus 1 plus constant. And in this formula, we are having an expression or a function of two terms, a t and a polynomial to the power 4 of power 4 and a cosine function. So we're going to first solve this and then cosine function. If you remember the sum and the difference rules, so this is basically saying t4 dt plus integral of negative cosine t dt. Negative is a constant, you can pull it out, and you can apply the normal power rule here, which is going to be t to the power 5 over 5 minus integral cosine t dt. Now if you go back, we know what is the integral of cosine t dt. Is a sine t. And that's what we write over here. This is t to the power 5. This is a final answer, guys. Over 5 minus sine t plus c. Remember, the differential of sine is cosine. This negative is a constant here. Okay, for the next problem, what we're going to do is we are going to first distribute the secant in sine, because we have not yet learned the integrals of product of two functions. So let's go ahead, open this up first. What do we get? Secant y tangent y minus secant square y, the whole with dy. Now, remember, the integral of secant and a tangent is nothing but secant. Let's go back here. So the integral of a secant with a tangent gives me secant, and the integral of a secant square is simply a tangent. And that's what we're going to do. We're going to apply these two right over in this problem. Okay. So now, secant y, tangent y, it's the integral of this is a secant y, tangent y. Now minus is a constant, so you just keep minus, and integral of secant square y dy, guys, we all know is tangent y. And after that, once you've done the integrals, in the end, simply write a c. Okay, now let's continue further. This problem has a rational function, which is a sine in the numerator and 1 minus sine square in the denominator. We'll have to go back to our trigonometric days of our pre-calculus, and we'll say, what is the Pythagorean theorem we can relate to, which will make our lives much, much simpler. Okay, so let's go ahead and look at our relationships. What is 1 minus sine square x? Okay, if you recall the Pythagorean theorem, that sine square x plus cosine square x is 1. So if I take the sine square on the other side, what do we get? We get cosine square x to be 1 minus sine square x. So now when we replace 1 minus sine square, we have cosine square. We have only one term instead of having two terms here in the denominator. So let's go ahead and replace it. So what we get? We get sine x over cosine square x dx. We'll do a little bit more algebra, because what is cosine square, guys? It is cosine times cosine. Let's write it here. Sine x over cosine x times 1 over cosine x dx. Now, remember what is sine over cosine? Tangent. And 1 over cosine? Secant. What does this become? This is tangent x, secant x dx. And we just did a problem here. Oh, I made a mistake, guys. This is secant y. Sorry, guys. This should be secant y. I made a mistake here. Yeah, I just read, yeah. So it's integral of secant y tangent y is secant y. Sorry, guys. Okay, so the same thing here. So tangent x secant x dx. So integral of tangent x secant x, guys, is simply a secant x. Plus a c. Guys, there are going to be mistakes. Just forgive me here. Okay, I'm glad I caught this mistake here. Okay, now let's look at this one, the last problem. We have tangent square x minus secant square x. Now, once again, we go back to our Pythagorean days, and what we know is that 1 plus tangent square x equals secant square x. That's one of the Pythagorean formulas for your trigonometry. So here we are given tangent square x minus secant square x. So let's get this here. So tangent square x minus secant square x, take the 1 on the other side, gives me minus 1. So this nice little function, tangent square minus secant square, is simply minus 1. Makes our life very simple. Okay, so we can write this one now as equal to minus 1 dx. And this is so simple to solve. Remember, minus 1 is a constant. It's a minus x plus c. Let me highlight the answer over here, guys. this is the solution to this problem. Thus, tangent square x minus secant square x dx is nothing but the integral of this is a minus x plus c. Now I would like you guys to practice some of these problems, and I have mixed the problems with the trigonometry with things we have learned earlier, applying our basic integration rules. Practice them as it will help you when we go further and deeper into our integrals. Thank you.